Hello world out there. I'm going to show you today how I set my runner length for 14 inches on this manifold. And so what happens is a lot of people don't really understand how to measure the I'm trying to do something here. Let me move this. I'm trying to line my setup underneath here. Basically what's going on is I'm getting ready to cut my runner lengths to a certain height. And right now, with this runner length, the way it's set at this angle, it's actually a 15-inch runner, even though longside to longside measures 18 inches. So you don't go by that. And basically what you're going to do is I'm going to show you how I measure it and how I come up with the runners. Now I use performance trends for all my calculations on the dyno, and with performance trends it's been super accurate when I get back on the dyno for testing. So in the case of this one here, so I'm going to show you what I'm doing right now is I'm basically setting my manifold down in place before I get ready to make my cut with the mill. So before I actually go milling out the oval on the bottom of the intake manifold, I actually use these pieces here for running down and holding down the intake manifold while I'm making some cuts, because I really have no way to secure it end to end. And so this is my preferred method for doing this, for holding this in place. But anyway, so let's get on to this. Let's get on the meat and potatoes and things here. So what I'm going to do is I'm going to snug this down real quick here. And what you saw underneath that it's sitting on is a 3D printed spacer that I use to hold the intake manifold up, and so you can see nice and solid, and it also keeps me from having to cut the very front bracket that holds that 9/16 9/16 nut, actually 9/16 bolt that goes into from the intake manifold in the front all the way to the alternator area right there, so you can keep that bracket. So that's why I have to lift this up before I start doing my machining. So anyway, so basically what we're doing here is what I'll do is I'll start on the very inside here for the shortest part of the runner, pull back on here, and I get 12 inches here. So you got 12 inches here, and then I go to the top side and then push all the way down, and I get 18 inches. So 12 and 18 put together divided by 2 gives you 15 inches of average runner length. So basically what I do is when I start milling on this intake manifold, I will take and start my runner length by my shortest distance here. So what I do is I take this shortest distance right here and I level all this out, and then I bring everything back square to it. So when the VRPs get set back in place, it's pretty much a straight shelf straight across. So I'm taking a pretty good 30-35 degree angle off it. It's going to be level, but I'm shortening the air where it comes in on the runner. So basically what's happening is instead of my angle for my entry for my airflow entering here, it's now entering here and flat against here, obviously with a wedge in the center diverting air each direction. Now there's two trains of thoughts. Intake pulse to intake pulse, obviously with a wedge diverter inside, I'm disrupting that flow, but I haven't seen any changes of how it performs on the dyno. My RPM still comes in great. I can shift these manifolds at 6,000 RPM easily. I mean, it's a roller cam, so its rate of fall off is going to be a whole lot less than what you would feel on a regular camshaft tappet setup. And So anyway, if I wanted to take these runners down, I could take this runner down even farther here, another inch, and go to say 11 inches here and straight across, and that would give me a runner coefficient in there lengthwise of around 13 inches. Well, the horsepower would be great, but the torque would start falling off. So as with each manifold that I put together, I try to calculate what truck this is going in and the weight of that truck and what the guy's doing. You know, if it's going in a lightweight Dakota and it's in a sandrail type setup going up the mountain for Little Sahara, Utah or something like that, absolutely. I'm gonna have 7-inch runners all the way down here at the bottom with none of this going on here. I'm trying to look around for my other manifold, I don't know where I put it. But anyway, I've got another manifold where you can see that matter of fact, let me go get it. Hold on. There you go. You can see that's the 7-inch, and it went all the way down and had a plate that set all the way lower to keep my plenum volume down to around 2,500 cc's. But you can see the runner was completely cut all the way down. And this is the manifold that made 403 torque on the dyno. I could have made more, obviously, if I'd had a longer runner manifold. So anyway, the optimum runner length that you want to stick with is going to be a 14-inch runner to keep the torque high and the horsepower average right around 5,200 RPM peak horsepower. And your peak torque is going to be 3,500 with this setup. So that's what we're doing. Just wanted to give you a quick video to show you exactly how I do my calculations there before I start running the mill down in here and cleaning all this up. And then once we get done, then obviously the VRPs are going to be trimmed, put in place, and they will be slid down in place and welded. I'll take weld all around here and whatnot, and that will give us our reduced volume that we want to stay 2,000 to 2,500 cc's. That's where the numbers seem to be best for a super heavy truck, whether it's your Jeep running, you know, 35s or bigger tires, or your Ram. Obviously, if you're drag racing and stuff like that, you definitely want to get into a different intake manifold for that, or go to something like that 7-inch right there over there. That manifold over there will pull 6,500 on the street. That one's crazy over there. But anyway, hope you enjoy this. Getting ready to put this one together for the 408 here in the shop. We've got a nice little 408 going together for the silver truck. And then we'll catch you next time. Take care.